Welcome to our Week 6 project update presentation. This is Direct Inc. with Rufena Kavere, Jimmy Kirika, Anthony Kiema, Jack Beja, Christopher Kwala, and Kevin DC. This week we are going to present on the essay questions, and Kevin DC will be the first one to go. Kevin, welcome.
Welcome and thank you for attending this meeting today. The first task that we are supposed to tackle for this week 6 is some of the various functions that are being provided by the operating system. The first function that is being provided by the operating system is program execution. We are having at number 2, we are having handling input and output operations. And then number 3, we also discussed the manipulation of file system. And then we had the error detection and handling. At number 5, we also discussed about the resource allocation. And then at number 6, the last but not least, we talked about accounting, information, and resource protection. Thank you. Back to you, Anthony.
Okay. The second question was asking, explain what is a virtual machines and the 3 advantages and 3 disadvantages. According to Gord Griffin, the author of Data Virtualization and Modern Computing, describes it as emulation of a computer system which involves a host and a guest. The host is the native computer that you're running and the guest is the emulated machine running the host. So the host computer is the physical computer with the hardware, and then the guest will be the virtual machines. Some of the advantages of such is that multiple OS environments can exist in one hard drive. So you can run different operating systems from one physical computer, and then there is high availability of data, especially when you are running multiple operating systems. You are able to access data from the other operating systems, and then data recovery is easy, usually if it is virtually backed up. So backing up data virtually prevents things like physical damage to computers that may be caused by maybe humans or maybe things like fire. So the disadvantages of having virtual machines is that a host machine is less efficient than the real one, or it gives unstable performance because it does not have direct access to the computer hardwares and software capabilities. And then the second reason is that since one may use different operating systems, prevention of malwares and viruses is not possible, and one may need to buy a different type of virus protection per the operating system. So for every operating system that you install as a virtual machine, you also need to install antivirus protection, because when you run different operating systems, it means that you need to find different virus protection softwares. And then the third disadvantage is potential downtime in case of a hardware failure in a system. So assuming you're running a virtual machine and then maybe the hard disk goes down, so that means that all your virtual machines will also go down. So that is one of the disadvantages. So I'll invite Jimmy Kirika to speak on the other points.
Okay, thank you. I'll take you through the next slide, which is the question is to write 2 examples of a Linux bootloader and Windows bootloader. The first example of a Linux bootloader is a Linux loader. First of all, we'll have to discuss what's a Linux bootloader, and it's a program that places the operating system of a computer into a memory. So Linux bootloader is the most common used, and its main advantage is to allow fast boot up. When starting the computer, it boots up very fast than the other bootloader. The other bootloader, which is Load Linux, it is more preferred by users who have multiple operating systems, like, let's say, Linux and Windows. It is used as a backup bootloader for Linux in case Linux loaders fail. On the next slide, we'll have the Windows bootloader, and it's a small piece of software called the boot manager. So this software is loaded from the volume boot code, and loader is an NT loader, which has the initials NTLDR. So it runs primarily on the hard disk, and it can also run from portable storage devices such as CD-ROMs, USB flash drives, or floppy disks. The next one is the Windows 7 loader, and all the key parts of the exploit are encrypted with a custom encryption. These exploits run before the system started up, so it's harder for Microsoft to prevent. Those are some of the bootloaders from Windows 10. I'll let Chris take you through the next slides.
Okay, my name is Christopher, and I'll be taking us through how a system can be designed to allow choices of the operating system to boot from. So operating system is already through a bootstrapping process, so more successively known as booting. So the bootloader is a program. The task is to load a bigger program. So the bootloader will specifically be able to load programs such as the operating system. The bootloader loads a second stage loader, which performs error checking, giving the user the choice of operating system to boot, the ability to load the fix software to enable diagnostic modes in the operating system. So the bootloader is a small program, but basically its functionality is broad, and therefore it makes operating system from the storage device set up a minimal environment in which the OS can run and run another operating system data procedure. It supports multiple booting, where the user is allowed to select between several devices or several different operating systems are working at the same time. Next slide. So what does the bootstrap program need to do? So the bootstraps will do this in order to for the with the booting process to start. So first, upon the startup, the BIOS goes through the following sequence. It's power on, then it detects the video card. After detecting the video card, then it detects any other devices that either are BIOS or invoke any initial function. Data displays the BIOS startup screen, then perform a brief memory test. After performing the brief memory test, then it goes to the set memory and derive parameters. Then it goes to the configure plug and play devices, after which it assigns resources to various channels. Then it identifies the bootstrap devices, like the first stage bootloader, then the second stage bootloader. The first at the bootloader task, the first stage, it runs the audio video processor, then it reads the files and initializes the DRM, then it checks the battery level, then after which it will load to the second stage bootloader, after which it will initialize the clock source and enable clocks to require peripheral devices. Then it powers up the CPU, enables the CPU clock, and takes up the CPU to restart. Then I'll allow the next person to take us through the next question.
So the next question is, when will a multi-threaded solution using multiple kernel threads provide a better support of a single threaded solution? So when this occurs when a kernel thread suffers a fault in a page. So another kernel thread can be switched into the interleaving time in a useful manner. A single threaded process, on the other hand, will not be capable of performing useful work when a page fault takes place, and that is the main difference between the two. So therefore, in such scenarios where a program might suffer from frequent page faults or has to wait for another system events, a multi-threaded solution will perform much better, even on a single processor system. Thank you.
Okay, for question 7, we have to explain with the text and the diagram the following: virtual memory and address translation. So virtual memory is a storage allocation scheme in which secondary memory can be addressed as though it were part of the main memory. And the size of the virtual storage is limited by addressing scheme of the computer and by the amount of secondary memory available, and not by the actual number of main storage. So here we have a diagram that shows where we have physical memory. Then we have an address space. Then we can see the virtual memory. And then we have a disk drive. Next slide. So under address translation, this is a method of remapping one IP address space into another IP address by modifying the network address information in the Internet Protocol datagram packet headers while they are in transit across a traffic routing device. So in a system with virtual memory, each memory access must be translated. And here we were asking if the OS can perform the address translation, and we learned that the OS can only perform address translations if the programs are interpreted. Then modern systems have hardware support that facilitates address translation in such a way that they are implemented in the memory management unit of the CPU. Then it cooperates with the OS to translate the virtual addresses into physical addresses. Next. So here we have the virtual address where we have a virtual page number and the page offset. So the virtual page number is translated into the physical page number, and then the page offset, it remains the page offset. Then we have a physical address where we have mapping. So this diagram talks about mapping from a virtual address to a physical address. So it's all about translation. So that's the end of our presentation. Thank you for your time.